learners. Our lesson for today is the second part of circular functions. Let us have first non-special angles. Let us have the general note first. It is important to emphasize that the function mode of the calculator be shifted from rad to deg or from degrees to radian as the case may be. To set the calculator in radian mode, just press shift mode and choose the number that corresponds to rad for radian measure. To go back to the degree mode, just press shift mode and choose the number that corresponds to deg for degree measure, and that is the normal mode. Different calculator models have different sequences in performing the operations. It is advised that the operations manual of the calculator being used be read. The sequences of the operations of the given examples here are based on Casio FX991ES Plus. Now, for non-special real values, the values of circular or trigonometric functions can be determined by using a scientific calculator. For example, you are asked to use a scientific calculator to find the value of the circular function in 4 decimal places. Let us have sine 8 degrees. 8 is a non-special angle. So first, you have to set the calculator to degree mode, that is D, if the given is in degree measure. So all you have to do is to press sine 8, then equals, and it will display 0.13917301. Hence, sine 8 degrees is equal to 0.1392. Take note, sine 8 degrees is just simply equivalent to sine 8. Next example, given tangent square root of 5. So again, you have to check your calculator if it is in degree mode. First, you have to press tan, then square root, then 5, then equals, and it will give you 0.0390465743. Hence, tangent square root of 5 is equivalent to 0.0390. So tan square root of 5 is equivalent to tangent square root of 5 degrees. Next example, cotangent negative square root of 3 over 4. So again, it should be in degree mode. So press tan, then negative square root of 3 over 4, then equals, then it will display negative 7.55764123 times 10 raised to a negative 3. Or it is just simply equivalent to negative 0.00755764123 Then, you have to press the inverse key, equals, and then it will give you negative 132.3164157. So, cotangent negative square root of 3 over 4 is equal to negative 132.3164. Note, cotangent negative square root of 3 over 4 is just simply equivalent to cotangent negative square root of 3 over 4 degrees. Another given is cosecant negative 6 degrees, 25 minutes, and 1 second. So, you have to check if it is in degree mode. Then, press sine, negative 6, the degree key, then 25, the degree key, 1, degree key, and then equals. And it will give you negative 0.1117628206. Then press the reciprocal key, equals, and it will give you negative 8.947519349. Hence, cosecant negative 6 degrees, 25 minutes, and 1 second is equivalent to negative 8.9475. Next given, sine pi over 9. Pi over 9 is a radian measure. So you have to set the calculator to radian mode if the given is in radian measure. So to set the calculator in radian mode, just press shift mode and choose number 4, which corresponds to radian or to rod. So you have to press sine, then pi over 9, then equals, and it will give you 0.3420201433. Hence, sine pi over 9 is equal to 0.3420. Next given, secant 5 pi over 18. So again, you have to check if the calculator is in radian mode, or in the calculator it will appear R. You have to press cos because cos is the reciprocal of secant. Then 5 pi over 18, then equals, and it will give you 0.6427871697. Then press the reciprocal key, x to the negative 1, then equals, then it will give you 1.55572387. Hence, secant 5 pi over 18 is equal to 1.5557. Next, let us have the inverse circular functions or inverse trigonometric functions. One of the more common notations for inverse trigonometric functions can be very confusing. First, regardless of how you are used to dealing with exponentiation, we tend to denote an inverse trigonometric function with an exponent of -1. In other words, the inverse cosine is denoted as the cosine to the negative of 1x. It is important here to note that in this case, the -1 is not an exponent, and so cosine to the negative of 1x is not equal to 1 over cosine x. In inverse trigonometric functions, the -1 looks like an exponent, but it isn't. It is simply a notation that we use to denote the fact that we're dealing with an inverse trigonometric function. It is a notation that we use in this case to denote inverse trigonometric functions. So if you wanted exponentiation, use the following. The cosine of x raised to a negative of 1, and this is equal to 1 over cosine x. There is another notation for inverse trigonometric functions that avoids this ambiguity. So, for cosine to the negative of 1x can be written as arc cosine x. For sine to the negative of 1x is equal to arc sine x. For tangent to the negative of 1x is equal to arc tan x. To evaluate inverse trigonometric functions, remember that the following statements are equivalent. Theta is equal to cosine to the negative of 1x equivalent to the equation x is equal to cosine theta. For theta is equal to sine to the negative of 1x, this is equivalent to x is equal to sine theta. And for theta is equal to tangent to the negative of 1x, this is equivalent to x is equal to tan theta. Let us have the theorems and properties of the inverse trigonometric functions. First, inverse sine function. This is defined by theta is equal to sine to the negative 1x, or theta is equal to arc sine x, and is equivalent to sine theta equals x. With x values between or equal to -1 and 1, and the theta values we have between or equal to -pi over 2 and pi over 2. For inverse cosine function, this is defined by theta is equal to cosine to the negative of 1x, or theta is equal to arc cosine x, and is equivalent to cosine theta equals x, with x values between or equal to negative 1 and 1, and the values of theta we have between or equal to 0 and pi. For inverse tangent function, this is defined by theta is equal to tangent to the negative of 1x, or theta is equal to r tan n is equivalent to tan theta is equal to x, with the x values between or equal to negative infinity to positive infinity. And the values of theta is between negative pi over 2 and positive pi over 2. In general, if you know trigonometric ratio but not the angle, you can use corresponding inverse trigonometric function to find the angle or to find the theta. This is expressed mathematically in the statements below. For trigonometric functions, input angles and output side ratios. So we have sine theta is equal to the ratio of the opposite side over the hypotenuse. And then for cosine theta, we have the adjacent side over the hypotenuse. And tangent is equal to the opposite side over the adjacent side. For the inverse trigonometric functions, input side ratios and the output would be the angles. So, sine to the negative of 1, we have the ratio here as the input opposite over hypotenuse, and it will give us the angle. Cosine to the negative of 1, so the input is adjacent over the hypotenuse, and it will give us the value of theta. And tangent to the negative of 1, we have the input opposite over the adjacent side, and it will result to the value of theta. For example, if you are asked to evaluate sine to the negative of 1, for the solutions, this is equivalent to sine theta is equal to sine to the negative 1 of 1. So we're letting theta is equal to the given. Then sine theta is equal to 1. We have to determine the angle, and the angle is between or equal to negative pi over 2 and positive pi over 2, whose sine is equivalent to 1. And the value of pi now is equal to pi over 2. Thus, sine to the negative 1 of 1 is equal to pi over 2, or simply equivalent to 90 degrees. And using your calculator, all you have to do is to press shift sine 1 equals, and it will display 90. Using the unit circle, the 90-degree angle has coordinate 0, 1, in which the value of sine is 1. So 90 degrees is also equivalent to pi over 2. You can use the concept of the unit circle, or you can use your calculator. And take note, 90 is just simply equivalent to 90 degrees. So all you have to do is to indicate the degree unit for your final answer. Next, given cosine of arc tan negative 1. For the solutions, you have to let theta is equal to arc tan negative 1. So you have to determine the angle, and the angle now, according to the property, is between or equal to negative pi over 2 and positive pi over 2, whose tangent is negative 1. So theta is equal to negative pi over 4. So arc tan of negative 1 is equal to negative pi over 4. And we have to take the cosine of the arc tan negative 1. So the cosine of arc tan negative 1 is negative pi over 4. And cosine of negative pi over 4 is equivalent to square root of 2 over 2. So cosine of arc tan negative 1 is simply equivalent to square root of 2 over 2. Using the calculator, just simply press cos, shift, tan, negative 1, equals, and it will give you square root of 2 over 2. Next, you evaluate secant arc sine 1/2. The answer is 2 square root of 3 over 3. So using the calculator, all you have to do is to press cos, shift, sine 1/2 equals. And it will display square root of 3 over 2. Then press x to the negative 1, the inverse key, equals, and it will give you 2 square root of 3 over 3. Next, find the measure of the angle R in degrees, minutes, and seconds. Given the point with coordinates negative 2 and 3 is on the terminal side of theta in standard position. Determine the exact value of trigonometric ratios for angle R. So, point P is in the second quadrant because the sign of x coordinate is negative and the sign of the y coordinate 3 is positive. So, for your trigonometric ratios, only sine and cosecant are positive in their signs. So this is the figure. You have the point with coordinates negative 2 and 3. So meaning this is your reference angle. The adjacent side is equivalent to 2 units and the opposite side is 3 units. So the hypotenuse is square root of 13. To solve for the hypotenuse, you have to use the equation of the circle, which is r squared is equal to x squared plus y squared. And x is equivalent to 2, y is equal to 3. So this is 4 plus 9 is 13. So r is square root of 13. And then identifying the trigonometric ratios. So sine r, it's opposite over hypotenuse. Opposite now is 3 square root of 13 over 3 because the opposite is 3 and the hypotenuse is square root of 13. And you have to simplify 3 over square root of 13 by rationalizing the denominator. Therefore, the final or the simplified value of sine r is 3 square root of 13 over 13. For cosine r, you have negative 2 square root of 13 over 13. Tan r is equal to negative 3 over 2. Cotangent r, just take the reciprocal of tan. For secant r, you have negative square root of 13 over 2. Just take the reciprocal of cosine and simplify. And then for cosecant r, you have square root of 13 over 3. Just take the reciprocal of sine r and then simplify. So these are the values of the 6 trigonometric ratios. Just take note that you have to remember the SOHCAHTOA in determining the circular or trigonometric ratios. Next, you have to solve for the angle. So to solve for the angle, let's take one trigonometric ratio, and that is sine r with the value 3 square root of 13 over 13. And r now is equal to sine to the negative of 1, 3 square root of 13 over 13. So applying the inverse trigonometric function. And the value of r is 56.30, 99, 32, 47. Now, this is just the value of the reference angle. And this is equivalent to 56 degrees, 18 minutes, and 36 seconds. And to take the value of r, which is in the second quadrant, that is 180 degrees minus 56 degrees, 18 minutes, and 36 seconds. Therefore, the correct value of r is 123 degrees, 41 minutes, and 24 seconds. Thus, the measure of angle R is equal to 123 degrees 41 minutes and 24 seconds since R or angle R is in the second quadrant. So using the calculator, you have to press shift sine 3 square root of 13 over 13 and equals, and it will give you 56.3932447. Then press the degree key and it will display 56 degrees 18 minutes 35.76 seconds. Just round off the seconds to the nearest whole number. If you would like to recheck the value of the angle, you can use another trigonometric function like secant r, and the ratio is negative square root of 13 over 2. So we can use the concept of inverse trigonometric function. R now is equal to secant to the negative 1 of square root of 13 over 2. And the value of R is 123.6900675. And converting this to degree, minutes, seconds, it will give you 123 degrees 41 minutes 24.24 seconds. Thus, R is equal to 123 degrees 41 minutes and 24 seconds. So all you have to do is to press shift cos negative square root of 13 over 2, the inverse key, equals, and it will give you 123.6900675. Then press the degree minute second key and it will display 123 degrees 41 minutes 24.24 seconds, and just round off the second into the nearest whole number. For the other solutions, you can do it yourself. Using the 6 trigonometric functions, it will give you the same value of R. The value of R is always 123 degrees 41 minutes 24 seconds if the given point is with coordinates negative 2 and 3 because it is found in the second quadrant. Next, let us have the graphs of sine and cosine functions. Let us have the graphs of sine and cosine functions. For sine function, let us recall that sine functions relate real number values to y coordinates of a point on the unit circle. So what do they look like on a graph on a coordinate plane? We can create a table of values and use them to sketch a graph. The table below lists some of the values for sine function on the unit circle. Supposing this is the unit circle and we're going to use the values of the coordinates. And let us just choose from 0 to pi as the value of x, and this will mean the angle. And for sine x, this will be the y coordinates of the trigonometric points. So for 0, the y coordinate is 0 here. Pi over 6, the y coordinate is 1/2. So it's here. Pi over 4, the y coordinate is square root of 2 over 2. It's here. Pi over 3, the y coordinate is square root of 3 over 2. For pi over 2, the y coordinate is 1. 2 pi over 3, the y coordinate is square root of 3 over 2. 3 pi over 4, the coordinate is square root of 2 over 2. 5 pi over 6, the y coordinate is 1/2. And pi, we have 0 as the y coordinate. So let us just stop until pi. Next, Plotting the points from the table and continuing along the x-axis gives the shape of the sine function. So, using this table of values, then we will be concentrating first the first quadrant. So, the 30 degrees, that is equivalent to pi over 6. And for 0, it will give us 0 for the y coordinate. So the point is here. For pi over 6, the y coordinate is 1/2. So 1/2 is located here. So the point is here. This is 1/2 with pi over 6. Then pi over 4, you have square root of 2 over 2. So somewhere here. Pi over 3, equivalent to square root of 3 over 2, somewhere here. Approximately 0.8660. And pi over 2, which is equivalent to 1. So it's here. So that is how to locate the points. So the graph now would be like this. You have 0, 0, pi over 6 with 1/2, pi over 4 with square root of 2 over 2, and so on and so forth. And plotting the other points below until 2 pi, you will go back to 0, and so on and so forth. Notice how the sign values are positive between 0 and pi, which corresponds to the values of the sine function in quadrants 1 and 2 on the unit circle. You can also graph the one in the third and the fourth quadrants. So what do they look like on a graph of a coordinate plane? We can create a table of values and use them to sketch a graph. So the table below lists some of the values for Let us have now the graph of the cosine function. Recalling that the cosine functions relate real values to x coordinates of a point on the unit circle. So what do they look like on a graph on a coordinate plane? We can create a table of values and use them to sketch a graph. The table below lists some of the values for the cosine function on a unit circle. So again, this is the unit circle and we will be using the x coordinates. So this is now the table of values. X will represent the angle and cosine x will represent the x coordinates. So for 0 degree, so for 0 radian, you have 1 as the x coordinate. So it's 1 here. Pi over 6, you have square root of 3 over 2. It's here. Pi over 4 square root of 2 over 2. Okay, you place it here. Pi over 3, you have 1/2 here. For pi over 2, it's 0. 2 pi over 3, it's negative 1/2. It's here. 3 pi over 4, it's negative square root of 2 over 2. It's here. 5 pi over 6 is negative square root of 3 over 2. And pi is negative 1. So we will be only until pi. So the graph of the cosine function, when we plot the points, it would be like this. So 0, so it's 1. Pi over 6 is somewhere here. 0.8660 or 0.9. Pi over 4, it's somewhere here. Then pi over 3, it's 1/2 here. Pi over 2 is 0, and so on. So from here until here, and then you will go back and then you can continue. So this is how the graph of cosine function looks like. Next, let us have the periodic function. In both graphs, the shape of the graph repeats after 2 pi, which means the functions are periodic with a period of 2 pi. A periodic function is a function for which a specific horizontal shift p results in a function equal to the original function. So we have f of x is equal to p of x plus p for all values of x in the domain of the function. When this occurs, we call the smallest such horizontal shift with p greater than 0 the period of the function. The figure shows several periods of the sine and cosine functions. So here we have the sine function. So from here until here, that's equivalent to 1 period. From here until here, that's another period. For cosine function, from here to here, it's 1 period. And then if you're going to extend from 2 pi to 4 pi, that's another period. So the period is 2 pi. Next, let us have the characteristics of sine and cosine functions. The sine and cosine functions have several distinct characteristics. They are periodic functions with a period of 2 pi. The domain of each function is with coordinates negative infinity to positive infinity. And the range is equal to negative 1 to positive 1. The graph of y is equal to sine x is symmetric about the origin because it is an odd function. The graph of y is equal to cosine x is symmetric about the y-axis because it is an even function. Let us have sinusoidal functions. Sinusoidal function is a function that has the same general shape as sine or cosine function. As we can see, sine and cosine functions have a regular period and range. If we watch ocean waves or ripples on a pond, we will see that they resemble the sine or cosine functions. However, they are not necessarily identical. Some are taller or longer than the others. Then we can have the general form of sinusoidal functions, and they are y is equal to a sine of the quantity bx minus c plus d, and y is equal to a cosine of bx minus c plus d. In general formula, b is related to the period by p is equal to 2 pi over the absolute value of b. If the absolute value of b is greater than 1, then the period is less than 2 pi, and the function undergoes a horizontal compression. Whereas, if the absolute value of b is less than 1, then the period is greater than 2 pi, and the function undergoes a horizontal stretch. For the solutions, if we let c is equal to 0 and d is equal to 0 in the general form equations of sine and cosine functions, so this is the general form, substituting 0 to c and d, then we obtain the forms y is equal to a sine of bx, because bx minus 0 is only bx plus 0, so it's only a sine of bx. And y is equal to a cosine bx. So here, the period is 2 pi over absolute value of b. For example, using y is equal to a sine bx. If f of x is equal to sine x, here b is equivalent to 1. The numerical coefficient of x is 1. So the period is 2 pi. If f of x is equal to sine 2x, then b is equal to 2. The numerical coefficient of x is 2, which will represent b. So the period is pi, and the graph is compressed. If f of x is equal to sine x over 2, then b is equal to 1 half. So the period is 4 pi, and then the graph is stretched. Notice in the figure how the period is indirectly related to the absolute value of b. We will have the solutions later on how to get the period. So let us have first the graph. This is the original graph, the orange one, for f of x is equal to sine x. And then for f of x is equal to sine 2x, this blue one, so this is now compressed, this graph here. And for sine x over 2, this is now stretched. So from here, it's stretched until here. Next, let us determine the period of the function given sine pi over 6x. So for the solutions, let's begin by comparing the equation to the general form. Y is equal to a sine bx. Given the equation, f of x is equal to sine pi over 6x. So b is pi over 6. That's the numerical coefficient of x. So the period will be p is equal to 2 pi over the absolute value of b. So 2 pi over 6. Then simplify 2 pi times 6 over pi. Cancel pi. So you will have 12. So the period is 12. Next, let us have the amplitude of the graph of sine and cosine functions. Amplitude is the maximum extent of a vibration, or the greatest distance from the rest. Returning to the general formula of sinusoidal function, we have y is equal to a sine times the quantity bx minus c plus d, and y is equal to a cosine times the quantity bx minus c plus d. We have analyzed how the variable b relates to the period. Now let's turn to the variable a so we can analyze how it is related to the amplitude. A represents the vertical stretch factor, and its absolute value of a is the amplitude. The local maxima is the plural of maximum, will be the distance of the absolute value of a above the vertical midline of the graph, which is the line x is equal to d, because d is equal to 0. In this case, the midline is the x-axis. The local minima, that is the plural of minimum, will be the same distance below the midline. So if the absolute value of a is greater than 1, the function is stretched. For example, the amplitude of f of x is equal to 4 sine x is twice the amplitude of f of x is equal to 2 sine x. If the absolute value of a is less than 1, the function is compressed. Okay, look at the figure. This figure compares several sine functions with different amplitudes. The blue one is the original f of x is equal to sine x, or 1 sine x. Then you have the orange, increases. Then you have the blue. And then you have now the maximum, or the highest curve, with the function f of x is equal to 4 sine x. And the lowest, or the minimum, you have for f of x is equal to sine x. Let us have the solutions. If we let c is equal to 0 and d is equal to 0 in general form equations of sine and cosine, here we substitute 0 to c and d to 0. Here c 0 and d 0. then we obtain y is equal to a sine bx and y is equal to a cosine bx. So the amplitude is a, and the vertical height from the midline is the absolute value of a. So whatever the numerical coefficient of sine and cosine, that's the amplitude. For example, what is the amplitude of sinusoidal function? F of x is equal to negative 4 sine x. Is the function stretched or compressed vertically? For the solutions, let's begin by comparing the function to the simplified form y is equal to a sine bx. So the given function is f of x is equal to negative 4 sine x. So our a is equal to negative 4 because the number beside sine is negative 4. This is the value of a. So the amplitude is the absolute value of a, which is the absolute value of negative 4 equivalent to positive 4. So therefore, the amplitude is 4. And the function is stretch. And this is the graph. So the amplitude is 4. From here, here it's 4. It's 4. And here it's also 4. Next, let us have the midline of the graph. While C relates to the horizontal shift, D indicates the vertical shift from the midline in general formula. Y is equal to A sine quantity bx minus c plus d, and y is equal to a cosine quantity bx minus c plus d for a sinusoidal function. The function y is equal to cosine x plus d has its midline at y equals d. Any value of d other than 0 shifts the graph up or down. So this is the illustration. For y is equal to a sine x plus d, this is the graph, and this portion is equivalent to d. Whatever the number here, that's the value of the midline, and that is y is equal to d. Let us have the graph of variations of y is equal to sine x and y is equal to cosine x. For a sinusoidal function is called the phase shift or the horizontal displacement of the basic sine or cosine function. If c is greater than 0, the graph shifts to the right. If c is less than 0, the graph shifts to the left. The greater the value of the absolute value of c, the more the graph is shifted. The figure here shows that the graph of f of x is equal to sine of the quantity x minus pi shifts to the right by pi units, which is more than we see in the graph of f of x is equal to sine of x minus pi over 4, which shifts to the right by pi over 4 units. So here, look at the original function or the parent function. F of x is equal to sine x, this blue one, and then for the orange one, sine of x minus pi over 4. So this is now the graph. While for sine pi x minus pi, so the blue one here, and this blue one is shifted to the right by pi units. So from here, shifted here by pi unit, and another here it's by pi, and also here by pi. So again, always remember the general form. Let us have the phase shift of the graph. This figure compares f of x equals sine x with f of x equals sine x plus 2, which is shifted 2 units up on the graph. Given the general equation, so this is the general equation, so c over b is the formula of the phase shift and d is the vertical shift. So this is the original y is equal to sine x, and when you add 2, it is shifted 2 units up. So it started here. So 2. From here to here, it's also 2. From here to here, it's 2. Next. For example, determine the midline, amplitude, period, and phase shift of the function y is equal to 3 sine 2x plus 1. So let us begin by comparing the equation to the general form. And given y is equal to 3 sine 2x plus 1, the value of a is 3 here. The value of b is 2 it's here. And the value of d is 1. And there is no constant after 2x, so c is 0. So the amplitude is the absolute value of 3, which is 3. The period is p is equal to 2 pi over the absolute value of p. So p is equal to 2 pi over 2, cancel, so it's pi. So the period is only pi. And for the phase shift, that is c over b, so 0 over 2, which is equivalent to 0. And for the midline, it is equivalent to d, so y is equal to 1. And the graph is like this. So the amplitude, that is equivalent to 3 units here. 1, 2, 3 here. So when you measure here, it's also 3. So this will give us the midline y is equal to 1. And the period from here to here is 2. Next. Determine the midline, the amplitude, the period, and the phase shift of the function. Given y is equal to negative 2 cosine of the quantity pi over 2x plus pi plus 3. And then graph. So again, let's always begin with the general form. And identify the value of a. A by this time is negative 2. It's the number beside cosine, negative 2. The coefficient of x is pi over 2. That's the value of b. And by this time, we have a constant that's negative pi because the original is negative c. So we have negative pi. And value of d is 3. So the amplitude is the absolute value of a, which is the absolute value of negative 2, so equals to positive 2. The period is 2 pi over absolute value of b, so that is 2 pi over 2. Simplify, so you cancel pi, 2 times 2 is 4, the period is 4. The phase shift is c over b, so negative pi over 2, then simplify, cancel this, so you will have negative 2. And the midline is 3. So the vertical shift is up 3 units. And this is the graph. Amplitude is 2. And you have the midline, which is 3. The period is 4. So 1, 2, 3, 4. So do you have questions? If there is none, see you next time. Since a is negative, the graph of the cosine function has been reflected about the x-axis. The graph shows one cycle of the graph of the function. If you would like to show 2 cycles or more, you can do it. Do you have questions? There is none. See you next time. Bye!